Hi everyone. Today we're looking at solving 3 by 3 systems of equations. Now these are all going to be linear, so notice everything's to the first power. The good news first is that we're just going to use the same methods, so it's going to be a lot of substitution and elimination still. The thing that's a little bit different with solving a larger system is that we kind of lose the graphical interpretation. It still works, but these are functions of, or because we have three variables here, these are actually, instead of being like lines that live in a two-dimensional plane, these are planes that live in three dimensions. So, each of these is some kind of plane that lives in three-dimensional space. And then what we're looking for is still an intersection. But because we're in three dimensions, it becomes harder to interpret graphically. And then, of course, if you go any higher than that in the dimension, um, it, it, you kind of lose the graphical thing altogether. But solving large systems like this can be useful in some applications, so we still need to be able to do it. Now, the main things I'm going to say are one, use substitution and elimination. I'll probably do more elimination here, just because it kind of helps keep things organized, I think, or for me anyway. Um, Two, and I don't know about the ordering here, I'm just making this part up, but um, keep the plan in mind. Um, So one thing that can happen here is that if we just start sort of doing things that jump out at you, so like looking at this one, I might see, hopefully we've done enough of this at this point that I might see plus y and minus y and think, oh, hey, if I can combine those, I can get y to drop out. But then if we're not sort of sticking to that plan of like eliminating y, you can end up doing things that work and that make sense and, just kind of chasing your, like running around in circles, right? Chasing your own tail, not really getting anywhere. So, um, and then kind of along with that, right, be organized. General idea is that we're going to use, again, our tools, substitution and elimination, to reduce this 3 by 3 system to a 2 by 2 system, then to a, single equation that we can solve. Once we have one thing, we just start kind of reversing our steps again and um, getting back to an actual solution. Okay, so how do we do this? The way that I'm going to organize stuff, I'm going to start by like labeling these equations. Call them ABC or 1, 2, 3 or something, just so that I can keep track of what I'm doing a little bit easier. So let's go with letters. Let's call this A and B and C. And then again, I'm thinking in elimination terms. So the thing that I just pointed out a second ago, y and negative y right there. So if I kind of notice that and like lock onto that idea, I'm going to write here that what I'm going to do is eliminate y. I can do that by taking a and b and adding them together, right? That would eliminate y. So let's see, here's equation A. Here's equation B. If we add those together, again, with the goal in mind of getting rid of y, notice that plus y, uh, y plus negative y is 0, so y drops out. That's what we were trying to do. And then add everywhere else. So 2x plus negative x and z plus z. And make sure to watch out for your z's not turning into 2's. Just be careful about that. we get a new equation that has x and z in it, right? So we've eliminated y. We get a new equation that only has the other two parameters. That's great, but only useful if we can find another one that just has x and z. So this is what I meant about, sort of keeping the plan in mind. I started by saying, hey, I'm going to eliminate y. What I need to do now is go back to the original system and find some other place that I can eliminate y. Just like with smaller systems, the big idea is that I need to take these three pieces of information, these three equations, and kind of merge them into one thing. So I need to eliminate y again. So if I start looking at the options here, the y terms, I might look at these two. And notice that if I take a and c and add them together, similar to what we just saw, I can eliminate y again. So 2x plus y plus z equals 9. That's equation A. 3x minus y plus z equals 9. That's equation C. Adding those together, again, with the goal of getting rid of y, we get 2x plus 3x, y minus y, which is 0, 2z, 9 plus 9 is 18. Now we've got one equation with x and z in it, and another equation with x and z in it. We've used a and b and c, so we've used all three of these equations. And essentially, we've combined them into these two things, which are two equations in two, and this part's important, the same two unknowns, right? Only x and z. If we had, xy here and xz over here, that doesn't help. We need two equations in the same two unknowns. So take those. Together and now solve the 2 by 2. This would be a really good place to pause and practice your skills at solving a 2 by 2 system. So I'll let you do that. And through the magic of recording, I can just keep talking now, I guess, because you paused it and now you're back. There are a lot of ways you could do this. It's a linear 2 by 2, so you kind of have your choice. This is the thing that jumps out at me, 2z and 2z. I'm going to subtract. Z goes away. Negative 4x equals negative 8. So x is 2. Hang on to that. If x is 2, then x plus 2z, right, this equation right here, becomes 2 plus 2z equals 10. So 2z equals 8. So z equals 4. Hang on to that. And then all the way back up to the top, if x is 2 and z is 4, then I'm just going to go with the top line because they're all going to end up being about the same. 2x plus y plus z equals 9. So y plus 8 is 9, so y is 1. The solution then to the system is the ordered triple, x, y, z, 2, 1, 4. That's how you solve a 3 by 3. Again, it's same ideas as with the smaller systems, just more of it. Hopefully, at this point, you're kind of getting comfortable with the mechanics, like doing this part, figuring out what to look for to make this happen. the kind of added layer of difficulty with the 3x3 thing is just this idea that we kind of need to have a plan in mind, so that you can stick to that. Uh, just being able to do this part is important, right? We need to be able to execute that. But if you don't have an idea of what you're trying to do, you can end up doing things like this. And I've seen this on tests before where people can do this part just fine, and they'll do like 4 or 5 different operations like this, sort of combining things together, but not really getting anywhere because they're not doing it with an idea in mind, right? Like if I did this and then maybe I took these two and I subtracted to get rid of z. Well, that's great, but if you subtract to eliminate z, you're going to end up with a thing that's got x and y in it, and that doesn't really help me when the other equation I have has x and z, right? So we need these two to kind of be the same type of thing so that we can then go on and solve that system. Once we get here and you have a value for one of them, we just kind of start working our way back up and finding the others, and hopefully it's kind of downhill from there. There are 2 other examples there. B and C solutions are in Blackboard, so try those first, and see what you come up with. The answers should be, they're all like integer valued solutions. So if you start getting weird fractions or something, maybe check all your arithmetic, right? That's the other thing here, is that there are a lot of little arithmetic things happening. So just be careful about that. But try those first and then go check solutions to check yourself. I wanted to also take a look at D, because here we need to set things up first. So I wanted to talk through that. So we've got 3 students buying lunch in the cafeteria. Again, we can just call them, ABC or 1, 2, 3 or whatever. One buys 5 hamburgers, 5 orders of, well, you can read. I'll just let you read it. Okay, so we have 3 items: hamburgers, orders of fries, sodas. We've also got 3 separate orders, right? So that gives us 3 equations and 3 unknowns. To set up the system, first we need to decide what stands for what. So I'm going to let X be the price of a hamburger. We've got information about the number of things that they ordered and about the total cost. So we're talking about price per thing then. Price of an order of fries is the price of a soda. Okay, so we sort of declare what our variables represent, and then think about interpreting what we have here. This first student buys 5 hamburgers. Okay, that's 5x, and 5 orders of fries. That's 5y, and 1 soda. So z, or 1z, equals 21. The total dollar amount, right, would be given by 5 times the price of a single hamburger plus 5 times the price of a single order of fries plus 1 times the price of a soda. So we get that first equation. Do a similar thing with the others. This would, again, be a good place to pause and do that for yourself. 1 hamburger, 2 orders of fries, 1 soda, $6. Did I write this in the 90s? What are these prices? And the third, 1 hamburger, 1 order of fries, $4. Okay, that's our system of equations then. Now we do want to solve that also. If we're going to solve this, we talked about this a little bit in class today or yesterday or whatever, the last time I saw you. And things that look different, sometimes we panic a little bit, but if you actually think about what's going on, to solve a 3x3 system, what we do is reduce it to a 2 by 2 system, right? So we want two equations in the same two unknowns. Hey, this equation's only got x and y in it, right? No z term appears. So if I can use the other two and get rid of z, we'll be in good shape. So what I'm going to do is take those two aside. Oh no, sorry, I forgot. I can't do that. 5x plus 5y plus z equals 21. And I'm looking at z here. If we subtract, z drops out. We get 4x, 3y, and 15. And then those together give us a 2 by 2, two equations, and again, they have to be the same kind of equation, right? X and Y, a 2 by 2 system that we can solve. Again, the solution to this is in Blackboard, so I'll leave it there and let you finish that and check. But that would be, how you could get into that. But again, I wanted you to also focus though here on how we did the setup part, right? The information we're given is about how many of these things that people bought and also the total price. So our unknowns are the price per item, and then if a single hamburger is X dollars, then 5 hamburgers would be 5X dollars, right? That's how we're getting the individual terms here. You add them all up to get the totals. That's how we're coming up with um, the system there. So, okay, I hope that gives you a good idea, good start on how to do the 3 by 3 stuff. Please take a look, work through those other examples, check solutions in Blackboard, and please let me know if you have any questions. Otherwise, I will see you in class.